The successful testing of Raptor 3 by SpaceX, which established a new thrust record, has recently caused a flurry of enthusiasm in the space community. However, when word of this groundbreaking achievement spread, it also sparked worries about the possible downsides of the formidable combination of Starship and Raptor 3. The possible influence on the integrity of the support systems and the surrounding environment is what raises the most worries. This made me take a close look at the circumstance. What is SpaceX trying to accomplish with this new engine? Is SpaceX creating the Raptor 3 in the wrong way? In this video's current episode, let's examine every aspect of it. Early in May 2023, Elon Musk reported a surprising accomplishment: the successful static fire test of Raptor 3, which generated an astonishing 269 tons of force for 45 seconds while operating at 350 bars or 5,100 psi. Compared to earlier SpaceX Raptors, this marks a substantial improvement, as we covered in great detail in the previous episode. Simply explained, when 33 Raptor 3 engines are installed in the Starship Super Heavy rocket, the total thrust would be an astonishing 877 tons or 19.5 million pounds. But first, we must examine the launch pad, which is the main problem at hand. It is important to recognize that significant harm has already been done even with only 33 Raptor 2 engines operating at 90% power for just 10 seconds. Therefore, using Raptor 3 engines, which provide a 20% power improvement, raises severe worries about the possibility of experiencing further negative impacts. Additionally, the infrastructure of the launch pad needs to be significantly reinforced to resist the increased thrust. For instance, NASA's current flame trenches are only intended for the Space Shuttle and the SLS. It's important to note that even SLS's launch tower sustained damage as a result of the system's overwhelming power. One is forced to wonder about the potential extent of Starship's harm to the launch facility given how powerful it is. The launch facility must undergo considerable and hard engineering work in order to meet the criteria required for withstanding such intense takeoffs. To ensure the safe and effective running of the Starship program after its initial orbital flight, several issues must be resolved. All of this begs the issue of why SpaceX is still working on these projects during a sensitive time when the FAA is looking into the Starship explosion. In fact, it's possible that there is still something about the engine that we don't fully understand. It's crucial to remember that just because the Raptor 3 has a higher maximum thrust doesn't necessarily mean it will use that level of power. This appears more like a test to ascertain the highest attainable thrust limit. If Raptor 3 can deliver a peak thrust of, say, 120%, it can operate at a thrust level comparable to Raptor 2 but under a great deal less strain. In other words, its main benefit is that it allows Raptor 3 to operate normally with a significantly bigger safety margin and less stress. The engine's durability is improved and several failures are permitted without endangering the whole vehicle by boosting their power, which allows the engines to run farther from their limits. Reusability is emphasized, which is essential. Starship is still in the early stages of development, while Raptor is getting easier to use and less expensive with each iteration. Since the Raptor crew is solely responsible for the engine, they are always working to improve it until it becomes essential to stop. The engineering work, which includes the creation of a deluge system, represents groundbreaking accomplishments, and it's quite likely that SpaceX will meet contractual obligations more quickly than any other firm in NASA's history and on an unprecedented scale. Thank you all for your support and valuable feedback. Your continued engagement motivates us to create more high-quality videos. Stay tuned for our next episode as we continue to explore exciting topics in the world of technology and space exploration. See you next time.